One minute, you're setting up a new space station orbiting Jupiter, and the next, you're plunging right into the middle of a giant red cyclone of death. What would the storm of all storms look like on the inside? How would it compare to storms back on Earth? And which one of Jupiter's tremendous forces would strike the lethal blow? This is What If, and here's what would happen if you fell into Jupiter's Great Red Spot. The Great Red Spot is the biggest storm in the solar system. At about 16,300 kilometers wide, well, it's large enough to swallow the Earth whole. It's a lot like a hurricane, only instead of lasting a few weeks, this giant storm has been rampaging for at least 300 years. And instead of forming from warm air, this monstrosity gets its energy from the dense atmosphere of Jupiter. Fueled by an abundance of the planet's hydrogen and helium, the Great Red Spot reaches 500 kilometers into its atmosphere. Oops, you should have built your space station a little farther away. Okay, well first, how on Earth would you even get to Jupiter? Well, if you traveled light and followed the route of the Voyager spacecraft, you'd arrive on Jupiter in just under 600 days, but this journey wouldn't be as simple as just pointing yourself at what appears to be a very bright star in the night sky. Roaming the solar system in a spaceship is a little more complicated than that. You see, the Voyager never intended to land on Jupiter, only to pass it on the way to interstellar space. So if you followed Voyager's path, you'd whip right past your target. For this to work, you'd need to follow the lead of the Galileo spacecraft, launched in 1989. Just like Galileo, you'd swing by Venus and then back around Earth for a little gravity assist. This way, you'd have the right speed to park in Jupiter's orbit. Only the trip would now take you 6 years instead of 600 days. By the time you reached Jupiter's moon Europa, the planet would appear 22 times larger to you than a full moon did back on Earth. And you'd still need to get a little closer. Now you'd be mesmerized by the planet's swirls and stripes. These are colored red, brown, and white, thanks to the sunlight reflecting off massive clouds made of ammonia and ammonium sulfide. Finally, you'd feast your eyes on the Great Red Spot, a giant twirl of the atmosphere rotating counterclockwise. It looks a lot bigger than you could imagine. But before you even begin your descent into the Great Red Unknown, your life would already be in grave danger. Jupiter's powerful magnetic field would shower you with intense radiation. I mean, luckily, you'd be equipped with a highly advanced protective suit, but it wouldn't be able to protect you from everything. As you approached the storm, you'd realize that you made a big mistake in your mission prep. Your plan was to build your space station at the same altitude as the International Space Station, 400 kilometers into Jupiter's atmosphere. Yeah, except this storm is as deep as 40 Mariana Trenches. So it would swallow you up before you could finish your project. But now it's too late. You'd be plummeting through the storm and you'd get your first real glimpse of how powerful it is. You'd be thrown around at wind speeds of about 400 kilometers per hour. To give you a sense of how insanely powerful that would be, hurricanes are ranked into 5 categories based on strength. A Category 1 storm has wind speeds up to 153 kilometers per hour, strong enough to snap large trees. In the middle, a Category 3 hurricane can hit 208 kilometers per hour, These storms could result in devastating damage, including pulling roofs right off of houses. Lastly, a Category 5 hurricane back on Earth has wind speeds of 252 kilometers per hour or higher. That packs enough of a punch to collapse buildings, but that's still only half as strong as the winds in the Great Red Spot. Thankfully, your body can withstand wind gusts as high as 800 kilometers per hour, but that doesn't mean it would be refreshing in any way. Without the protective face gear, your skin would look as if it was melting straight off of your face. So make sure to hold on to that helmet tight. Not that you'd be able to do much else besides staying on a violent downward trajectory at this point. As you were falling into Jupiter, you'd see how clouds around you would change. First, you'd get a real close-up view of those ammonia and ammonium sulfide clouds you were mesmerized by before. Then you'd pass through clouds made of water, just like the ones on Earth. The temperature and pressure all around you would be changing too. Sadly, none of this would be comfortable for you, especially not at the same time. Where the atmospheric pressure is similar to that of sea level back on Earth, it would be a very chilly minus 110 degrees Celsius. And where the temperature was bearable, the pressure would be 8 times greater than what it was back on Earth. Now, the chances of surviving up to this point would be slim. I mean, look no further than the fate suffered by the Galileo probe. As it descended further and further into Jupiter, it encountered extremely high temperatures. And what do you think happens to a probe in that environment? Yeah, it vaporizes. Without a spacesuit strong enough to withstand all that heat and pressure, you'd end up disintegrating, just like the probe. Now you'll be one with the gas giant forever.
What if Jupiter gained just a little bit more mass during its formation period and then ignited to become a star? How different would our solar system have turned out? Would having another star in the middle of the solar system mess with the orbits of the planets? And would we see it from here? This is What If. And here's what would happen if Jupiter became a star. Jupiter has more than twice the mass of all the planets in the solar system combined. It doesn't have a solid ground and is made up of the same elements as the Sun, and yet it's not a star. Jupiter doesn't have enough mass to initiate a fusion reaction in its core, the necessary requirement to be accepted into the star club. If only we could find 79 more Jupiters and crash them all into the one we have now, we'd be able to build a second star in the solar system. What would that be like? 80 Jupiters crushed together would make a star out of the gas giant, but that star would be nothing like the Sun. Jupiter would be massive enough to become a red dwarf, a small, cool, hydrogen-burning star. And, as every red dwarf out there, it wouldn't be too bright. 0.3% of the Sun's luminosity is the most light that Jupiter could hope to spit out. Because Jupiter is 4 times further away from us than the Sun, the Earth wouldn't get much heat from it. By and large, Jupiter turning into a red dwarf wouldn't change anything for life on Earth. You'd still be able to see it from Earth. A Jupiter star would appear red and a bit brighter than the Moon at its full phase. Would it at least have a gravitational impact on the solar system? Not as much as you might think. The former gas giant would slightly shift the orbits of the other planets, but not enough to set them on a collision course with one another, or to launch them out of their orbits into outer space. The only threat we'd face would be space rocks from the asteroid belt that Jupiter might send towards the Earth. We'd need to learn how to detect and destroy them before they could reach our planet. Other than that, not much would change for the solar system. Things would get a lot more fun if Jupiter was replaced with a Sun-like star. If our gas giant became 1,000 times more massive, the solar system would go wild. Asteroids would crash into planets, and planets would change their orbital course. It's hard to predict what would happen to Earth in this gravitational mess. It could be anything from being pulled a little too close to Jupiter's star and getting scorched, to being left drifting alone in the void of space. In any case, it wouldn't be too pretty. In the real world, Jupiter is forever destined to be a planet, and that's for the best. The observable universe has a diameter of about 92 billion light years. Within it are planets, nebulas, asteroids, the list goes on. But what would happen if we got rid of a single planet? Specifically, our largest planet, Jupiter. How important is this gas giant to our solar system? How would it affect life on Earth? And how would this change Earth's development? This is What If, and here's what would happen if Jupiter never existed. If Jupiter was no longer in our solar system, having one less planet to aspire to travel to would be the last thing we'd have to worry about. This gas giant ranges from 600 to 1,000 million kilometers away from Earth. But despite it being so far away from us, we'd experience direct implications right here on Earth. Why is this? Well, to say that we'd notice Jupiter's absence here on Earth is a bit of an understatement. This is due to Earth not being around, at least not in the current state as we know it today. Sure, it would still be some sort of planet, but it's very unlikely that there would be any complex life forms. No fish, animals, and certainly no humans. Earth has been hit by tons of asteroids and other space rocks. According to some experts, they may have brought water and other essential substances down to Earth. But although some asteroids can be good, there's plenty of bad ones. Some would be big enough to wipe out entire civilizations, just like what happened to the dinosaurs 65 million years ago. This is where Jupiter's role comes in. Although it has slipped up a couple of times throughout the history of our solar system, Jupiter has been protecting us. As millions of asteroids have been heading towards Earth, Jupiter's gravitational pull has grabbed the asteroids. This puts them in Jupiter's orbit and unable to reach Earth. Without our giant protector, Earth would be hit by a lot more asteroids. And it's unlikely that another planet would step in to fill Jupiter's place, considering that the gas giant is the only planet big enough to attract all these asteroids. This means Earth would get hit by thousands more asteroids than it ever has before. Some would be small and could maybe help Earth, bringing us new elements. But it's possible Earth would get hit by a couple of big ones. Enough to destroy anything that would be evolving on the planet, and maybe enough to destroy Earth itself. So, we know we probably wouldn't be here if Jupiter had never existed, but what if it suddenly disappeared today? Our solar system would have developed in the exact same way, but Jupiter suddenly blinked out of existence. For more on how our solar system as a whole would shift and get all out of sorts, you can check out our episode, What If Earth Was the Only Planet in Our Solar System? But if only Jupiter disappeared, it might be a good thing. Despite being our protector, occasionally Jupiter messes up and might miss a couple of things. Jupiter threw a comet towards us 350 years ago. Luckily it missed us, but it wouldn't have been anywhere near Earth in the first place if it wasn't for Jupiter. Despite Jupiter occasionally throwing some space rocks our way, it has largely helped us throughout history. So I'm going to say it's probably best to let Jupiter stay in our galaxy.
Jupiter may be the biggest planet in the solar system, but its days are numbered. Because today, we're using Earth's biggest, baddest bombs to blow the gas giant into oblivion. How many nukes would you need to do the job? What obstacles would these rocket-bound bombs encounter on the way? And Would one nuclear explosion ignite the entire planet? This is What If, and here's what would happen if we nuked Jupiter. Nuclear weapons are so powerful that even the low-yield versions, like those dropped on Japan by the United States in World War II, have the explosive equivalent of 15 to 20 kilotons of dynamite each. What makes them so volatile is that they harness the intense energy-releasing power of nuclear fission or fusion. These are the same processes that happen in our very own sun. So be careful when moving these things out to Jupiter. One false move and you could be incinerated by a fireball as hot as the center of the sun. In order to blow Jupiter to bits, one single bomb wouldn't necessarily be up for the task. Good thing for this scenario that there are a lot of nuclear weapons on Earth. Maybe the safest plan would be getting them all off our planet anyway. Given the top-secret nature of military activities, it's hard to know the exact number, but estimates put the global arsenal at about 12,700, with the United States and Russia battling for top spot with 5,500 to 6,000 weapons each. Okay, there's no use in delaying. Let's get these rockets off Earth as fast as possible. The distance between Earth and Jupiter fluctuates from about 590 million to 970 million kilometers. In the past, missions like the Galileo space probe took nearly 5 years to make the journey to the gas giant. But our rockets wouldn't take this long. Galileo had to be slow enough to enter Jupiter's orbit. We just need to hit the planet head-on, so you'd only be looking at about 550 to 650 days to get the job done. You shouldn't be too reckless and speedy, though. You don't want to nuke something else by accident. Now, bypassing the Moon and Mars would be easy enough, but getting safely through the asteroid belt would be like navigating a minefield. There are millions of asteroids riddled between Mars and Jupiter, and while the average distance between them is a not-so-worrisome 966,000 kilometers, sometimes it can still get a little cramped in there. And Jupiter is partly to blame for this. The planet's massive gravitational influence causes many of these to group into clusters known as families. Carelessly navigate through one, like the Flora family, and you'd better hope none of our rockets would collide with any of its 400 asteroids. For the best chance of success, you should aim to transport your rockets through the Kirkwood gaps. These are nearly asteroid-free regions in the belt, because you'd hate to see all of our planet's nukes detonate themselves in a blinding chain reaction before reaching our target. As the first of our bombs exploded on Jupiter, you'd see bright flashes back here on Earth. Just like when the Shoemaker-Levy 9 comet slammed into Jupiter in 1994. But that only released 5% as much energy as the Tsar Bomba, the largest bomb ever created. So, with thousands of our nuclear bombs, Jupiter's days would have to be numbered, right? Well, not exactly. Even though our nukes could produce an explosion hotter than the sun, this wouldn't cause all the hydrogen on Jupiter to ignite. It just isn't dense enough to sustain nuclear fusion. And even if every bomb was detonated, Jupiter wouldn't blow up completely either. In order to do that, we'd need to unleash as much energy as the sun releases over 160 years, all at once. And for that highly energetic result, about 1 billion nukes would be required. Somewhat more than the 12,700 in our arsenal. To build that many bombs, you'd need a combined mass of material that would almost be twice that of the largest moon in the solar system, Jupiter's Ganymede. No small feat, since it's bigger than Pluto and Mercury. Ever feel like the Earth is just too small? Well, let's make it bigger. Much, much bigger. Welcome to a new Earth that is just as big as Jupiter. In what ways would Earth change? What things would stay the same? And how would this affect you? This is What If, and here's what would happen if Earth were the size of Jupiter. A super-Earth is a planet with a mass up to 10 times bigger than the Earth. But don't let the name deceive you. These super-Earths aren't anything like the Earth you know. These planets could be rocky or covered entirely in ice. They could even be gaseous like Neptune. But if you want to make the Earth as big as Jupiter, get ready to make a super, super, super Earth. While Earth, as it exists now, is much smaller than Jupiter, it is a pretty dense rock compared to the gas giant. Our new planet would be massive, about 1,300 times bigger than Earth today. And that's not the only thing that would be different. Jupiter has a radius about 11 times that of Earth. Get used to a little more gravity when you walk around. Yeah, 11 times more. So, if Earth was this huge, how soon would the gravity completely crush your body? This change in size would have enormous implications for you and all other life on Earth. The first thing you'd notice with 11 times the surface gravity is that you would weigh more. And there's not much a diet plan could do to change that. You'd be 11 times heavier than you are now. So, if you currently weigh 70 kilograms, well, get ready to start lugging a hefty 770 kilograms around. Would you even be strong enough to carry your own weight? Well, you'd be heavier than the world deadlifting record of 501 kilograms held by Game of Thrones star Hafthor Bjornsson. So, yeah, good luck. But if you were a couch potato, this could be good news. Getting up from the couch wouldn't be an option. You wouldn't have the muscle strength. Even breathing would be a near impossible task. Scientists have concluded that the maximum gravitational field that humans could adapt to is about 5 times the gravity of Earth. Well, now double that, and that would be your new normal. And you wouldn't be the only one feeling heavier. All that gravity would result in increased atmospheric pressure. Yeah, you'd feel the air pressing down on you. This would have severe environmental impacts. Water molecules would need more energy to escape their liquid form. That means the boiling temperature of water would be much higher than 100 degrees. And the freezing point would now be way below 0 degrees. It would be harder for you to make ice. And even the large chunks of ice, like icebergs, could melt away. And there would be disruptions beyond life on the surface of Earth. Introducing a massive planet into the solar system would create some serious instabilities. Our moon would experience extreme changes in tidal forces. This gravity could be strong enough to pull the moon apart into teeny tiny pieces. The only remnant you'd have left would be a new ring of debris forming around Earth. The sun would still be 250 times more massive than our new Earth, so Earth wouldn't steal any planets away, but our super-Earth could have some effect on their orbit, just as Venus and Jupiter impact our orbit and climate today. The Earth would affect the orbits of other celestial bodies like asteroids. Our gravitational pull could be strong enough to eject these objects from the asteroid belt and set them on a collision path with you. And that would be bad news. Remember, you wouldn't be able to move a muscle to escape. So maybe it's better if Earth stays the same size as it is now. Uh-oh, looks like somebody left the gas running on Jupiter. Don't do anything stupid like lighting a humongous match. What would a match need to be made of to ignite this gas giant? How big would it have to be? And how much damage would this explosion do to our solar system? This is What If, and here's what would happen if you lit a match on Jupiter. Okay, you've heard me say this before. Jupiter is the largest planet in our solar system. It's 300 times more massive than Earth, but it's less dense than our home. With no solid surface, this planet is almost entirely gaseous. It has an atmosphere composed of 90% hydrogen, about 10% helium, and trace amounts of methane and ammonia. With so much hydrogen present, pretty much all of Jupiter must be flammable, right? So, if you lit a match, how much of that wooden stick would burn off before it all goes kaboom? Okay, before you go ahead and strike that match, there's one big catch you didn't account for. Fire needs oxygen. Without any oxygen in Jupiter's atmosphere, it would be impossible for the planet to erupt in flames. Not only that, but lighting your match would be difficult, to say the least. Usually, when you drag a matchstick across the red strip on your matchbox, you start a series of small chemical reactions that end in a flame. When you apply friction to the box, red phosphorus converts to white phosphorus. This mixes with the oxygen in the air and ignites. Without oxygen, this ignition wouldn't happen. But since you're so determined to set Jupiter on fire, you'd have to find a way around this obstacle. For starters, you'd need to reinvent the matchbox. You'd need one that could ignite the match without the need for external oxygen in the atmosphere. So you could lose the white phosphorus in your match. Instead, you'd need a match that could generate enough heat from friction to break down potassium chloride on the matchstick into oxygen. The flame would keep burning as long as the matchstick coating lasted. But one matchstick wouldn't provide you with the oxygen you'd need to ignite Jupiter. You'd need a lot more. Again, considering that Jupiter is the most massive planet in our solar system, you'd be burning off an astounding amount of hydrogen. To be precise, about 1.4 multiplied by 10 to the power of 27 kilograms of the stuff. For hydrogen to combust, you'd need about half as much oxygen present in the atmosphere as there is hydrogen. As you might have guessed, you'd need to gather a lot of oxygen. And because molecules of oxygen are way heavier than molecules of hydrogen, the total mass of oxygen we'd need would be about 6 times the mass of Jupiter. Yeah, there isn't enough oxygen in the entire solar system for this to happen. Sorry to disappoint you, but Jupiter won't be erupting in flames anytime soon. And before you try to get creative with your methods, let me tell you that even the most energetic impact that ever occurred on the gas giant didn't cause a single spark. In 1994, the comet Shoemaker-Levy 9 crashed into Jupiter. As it entered the atmosphere, it broke into multiple pieces. Some were as large as 1 kilometer in diameter. The total impact of all these pieces was massive. So massive that the total kinetic energy was many times more powerful than the Hiroshima nuclear bomb. But still, no flames. Still feeling destructive? Well, maybe you could see what would happen if Jupiter and Saturn collided. The two biggest planets in our solar system in one telescope view. Catastrophe is imminent. If Jupiter and Saturn suddenly were on a collision course, which of the two planets would emerge victorious? How would the composition of these planets affect the outcome? And what impact would this have on the rest of our solar system? This is What If, and here's what would happen if Jupiter and Saturn collided. On December 21st, 2020, Jupiter and Saturn were closer than they've been in nearly 400 years. This legendary event has an epic name: the Great Conjunction. You could see both planets in the same telescope view. They appeared as a single star in the evening sky, but they were still pretty far from an astronomical collision. If the two gas giants came a little closer, it wouldn't be the first time Jupiter has gone head-to-head with another planet, and you can probably guess who won that battle. Both Jupiter and Saturn are almost entirely gaseous, primarily consisting of hydrogen and helium. And while they may have solid cores, there's no sharp transition between the layers. Jupiter would have some significant advantages. It's about 3 times as massive as Saturn, with almost double the volume. And it's moving faster too. Jupiter's rotation speed reaches 13 kilometers per second, while Saturn rotates at just below 10 kilometers per second. But Saturn brings a wild card to the fight. Within its 2 rings, there are at least 150 moons and moonlets. If the planets drew closer together, Jupiter's strong gravitational pull would cause these moons, moonlets, rocks, dust, and ice to accelerate toward it. Some of them would be torn apart. That's what happened when the comet Shoemaker-Levy 9 collided with Jupiter in 1994. Originally, the comet was nearly 2 kilometers wide. But by the time it crashed, Jupiter's gravity had torn it to pieces. And those fragments smashed into Jupiter with the force of 300 million atomic bombs. Yeah, and that heated Jupiter's atmospheric temperature to nearly 40,000 degrees Celsius. Titan, Saturn's largest moon, is over 2,000 times larger than that comet, so the force of it alone colliding with Jupiter would be massive. If Jupiter and Saturn collided, they would begin to merge. Their atmospheres would mix. That would raise the temperatures in the top layers of the gas giant's atmospheres. It would get so hot that Jupiter would experience a chemical reaction, gaining more iron, silicates, and even water. Eventually, Jupiter would absorb Saturn, or most of it. Scientists at Sun Yat-sen University in China modeled a scenario about what happened when a massive planetary embryo, about 10 times the size of Earth, collided with Jupiter 4.5 billion years ago. The impact was so energetic that it destroyed Jupiter's original compact core. This formed a more diluted core composed of a dense mix of liquid metallic hydrogen and helium. But if Jupiter collided with Saturn, that event would be 10 times more massive. Large amounts of material would spread out in space, and then all that material would come together into a single planetary object. We'd call it New Jupiter or Jupiternus. And maybe that new planet would cause more trouble in the solar system than you might expect. Jupiter is sometimes referred to as a failed star. That's because its size and composition are similar to a brown dwarf. But Jupiternus would be more massive and have higher internal pressure. If the temperature was high enough, this could cause nuclear fusion in its core. Yeah, Jupiternus could become a star. And the impact of having 2 stars in our planetary neighborhood would be huge. It could even mean the end of life on Earth. Now, don't worry, if these 2 planets merged, Jupiternus would have a mass 30% greater than Jupiter, but for nuclear fusion to ignite, the planet would need to reach a mass of 75 Jupiters. So, life on Earth would go on, but this would be a spectacular show with tons of gas and debris expelled. Maybe it would all be illuminated by the sun, giving us a beautiful, glittering end to Saturn as we know it. Hey, at least this time Jupiter didn't go on a rampage and swallow every planet in our solar system, including Earth. You start your day hearing wild news. Jupiter has just swallowed Saturn. And it doesn't stop there. Jupiter is on its way to swallow every planet in the solar system. How big would Jupiter get? What would you see from Earth? And would Jupiter get rings like Saturn? This is What If, and here's what would happen if Jupiter swallowed every planet in the solar system. Jupiter has swallowed a planet before. Around 4.5 billion years ago, a protoplanet slammed into the young Jupiter. The protoplanet was 10 times Earth's mass, made of rocky and icy material. Jupiter's core broke apart and denser material mixed with hydrogen and helium. A few billion years later, the heavy material settled back into the dense core that we see today. Now, swallowing a single planet is one thing, but could Jupiter eat up all 7? In this scenario, you're going to see the planets get swallowed from largest to smallest, although we're saving Earth for last. Jupiter's first victim would be Saturn. From Earth, you could see these gas giants as 2 bright stars. And if you were to look up at the night sky as Jupiter swallows Saturn, well, all you'd see is Jupiter getting super bright. But if you were closer to the action, you'd see complete chaos. Jupiter is only 3 times heavier than Saturn, so it would be swallowing a planet that's almost its size. First, their moons would collide, creating massive amounts of debris. Some moon remnants would rain down on Jupiter, and some of the debris would float in space. As Jupiter was crashing into Saturn, Jupiter's surface temperature would become hotter than the sun's outer layer. Whatever remained of Saturn would mix in with Jupiter's atmosphere. They would become one. Now, swallowing Saturn would increase Jupiter's mass and gravity by 30%. Jupiter would also sport prominent new rings from the shattered moons. Next, it would envelop the 2 ice giants, Uranus and Neptune. The 27 moons of Uranus would collide with the rings of Jupiter, adding to the floating debris. Uranus has an icy core made of water, methane, and ammonia, but Neptune's inner core is rocky. Regardless, both cores would melt as the planets crashed into Jupiter. Now, Jupiter would be almost 40% heavier, and it would head towards its first rocky planetary snacks. The rocky planets, Venus and Mars, wouldn't even make it to Jupiter's core. They'd burn up in Jupiter's atmosphere as if they were mere asteroids. Then, we'd see our last planetary neighbor disappear inside this bulked-up Jupiter. Mercury is even smaller than Jupiter's largest moon, Ganymede, so it would get ripped apart by Jupiter's rings, adding to the speedy debris. Now,
only Earth and Jupiter would be left, and Earth would be in big trouble. But how would Jupiter go about swallowing our planet? You know, even in its normal state, without swallowing 6 planets, Jupiter's gravitational force affects Earth. Yeah, every 405,000 years, the pull of Jupiter and Venus makes Earth's orbit wobble. It causes hotter summers, colder winters, and more rainfall in the tropics. And now, Jupiter's gravitational pull would be over 40% stronger. But Jupiter's pull would still be no match for the Sun's gravitational force, so Jupiter would have to come for Earth just like it swallowed all the other planets in our solar system. Jupiter doesn't have a hard surface like the rocky planets. You could say Jupiter is a big, dense ball of gas. Its surface is defined as the point where its atmospheric pressure is equal to Earth's. Well, so could Earth simply pass through? No. Just like the rest of the planets, Earth and all life on it would be toast. First, we'd be bombarded by asteroids while passing through Jupiter's rings. I doubt anyone would survive this, but if they did, they would see the Earth igniting as it enters Jupiter's atmosphere. Jupiter is so massive that even if it were to swallow its 7 planetary neighbors, it wouldn't even double in size. As our biggest planet, Jupiter's immense presence helps to hold our solar system together. Its massive size and gravitational pull give it a dense atmosphere, a turbulent mix of hydrogen and helium. This results in unfathomable storms that have lasted for centuries. But let's imagine Jupiter came in closer contact with an even bigger object, the Sun. Would the Sun strip Jupiter of its atmosphere? And if so, what would that look like? What makes Jupiter such a unique gas giant? What is Jupiter's core made of? And what are hot Jupiters and hot Neptunes? This is What If, and here's what would happen if Jupiter lost its atmosphere. Jupiter's gravity is nearly 2.5 times stronger than Earth's, making it difficult for any atmosphere to escape. Thankfully, it also keeps out incoming asteroids. Jupiter has dense layers of gas consisting of 90% hydrogen, 10% helium, and a few traces of ammonia, sulfur, methane, and water vapor. It has an extended dilute core made up of rocky material, ice, hydrogen, and helium. And unlike Earth, there's no sharp transition between Jupiter's core and its outer atmosphere. Scientists believe the core could have been formed from a head-on collision about 4.5 billion years ago between Jupiter and a planetary embryo 10 times more massive than Earth. A recent discovery of the exoplanet LTT 9779b by NASA's Transiting Exoplanet Survey Satellite, or TESS, may unlock even more answers to Jupiter's formation and possible destruction. NASA's discovery of the Jupiter-like exoplanet LTT 9779b has captivated the scientific community with its miraculously close orbit to its star. While Jupiter maintains a safe distance from the Sun, LTT 9779b is so close to its star that its atmosphere is evaporating at an accelerating pace. What makes it so unique is that close orbits are usually reserved for Earth-like or Jupiter-like planets, but LTT 9779b is somewhere in between, closer in scale to Neptune. With an ultra-hot temperature of about 1725 degrees, astronomers have unimaginatively named it Hot Neptune. Oh yeah, clever guys. Personally, I would have gone with the Blue Inferno. Astronomers believe that the exoplanet may have formed further away from its star and has slowly made its way closer and closer over millions of years. The closer it gets to its star, more and more of its atmosphere evaporates, giving it a squished, almost football-like appearance. American football. LTT 977b is losing its atmosphere because it has surpassed the critical distance where a planet begins to lose mass due to the tidal forces caused by another celestial body. This is known as the ROCHE limit. Luckily, Jupiter is far enough away from the Sun to maintain its mass. And its moons are far enough away from Jupiter not to be absorbed. So, why do most gas giants, like Jupiter, reside so far away from the Sun? Well, all planets were built in the same way. The Sun's gravity pulled dust and rock together, while the Sun burned off gases such as hydrogen and helium in the inner solar system. The outer parts stayed cool. This provided just the right temperature and materials for planets to form atmospheres. Some astronomers have suggested that there are Earth-like planets out there that may have once been gas giants. For unknown reasons, they have entered the ROCHE limit and lost all their atmosphere, becoming hot Earths. There are even hot Jupiters out there, like the exoplanet 51 Peg, which is similar in scale and orbits its star every 4 days. For Jupiter to start losing its atmosphere, it would need to come closer to the Sun and surpass its ROCHE limit. While this isn't likely to happen, if Jupiter got nudged toward the Sun, it would slowly start to spiral closer and closer to it. It would lose more mass with each orbit. Eventually, it would get so close that it would orbit the Sun in a single day, 88 times faster than Mercury's orbit. The Sun's strong solar winds would give Jupiter a tail of gas like a comet. This enormous amount of gas could cloud the light of many stars, making our night sky much less impressive. During this slow process, Jupiter would be squished and eventually lose its atmosphere. It would be left looking like a barren, rocky planet, like Mercury, but about the size of 11 Earths. As we continue to explore and discover more exoplanets like hot Jupiters or hot Neptunes, scientists can better understand planet formation, which is vital to our understanding of the universe. The Earth has been hurtling towards Jupiter for the past 242 days. And now, it's about to make impact. Now, we're so close to the giant planet that it's the only thing that fills our sky. Ground temperatures on Earth are rising uncontrollably. Our atmosphere is igniting into flames, and the scientific community is scrambling to provide answers. What will happen when the two planets collide? Is there any chance that we could pass right through the gas planet? And how would this collision transform Jupiter forever? This is What If? And here's what would happen if Jupiter swallowed Earth. One way that scientists could find answers would be by looking into the past, because this wouldn't be the first time that Jupiter has collided with another planet. Nearly 4.5 billion years ago, Jupiter was involved in a violent collision with a planet 10 times the mass of the Earth. In that case, the collision completely transformed Jupiter's core, but what happened to the other planet? And what can that tell us about our own planet's chances of surviving a crash into the gas giant? To get some answers, let's travel back to 4.5 billion years ago, when Jupiter was just a young planet trying to find its place in the universe. Back then, Jupiter's gravitational pull became 30 times more powerful in just a fraction of a million years. This destabilized the orbits of nearby infant planets and caused some of them to crash into Jupiter. It's believed that one such planet was 10 times the mass of Earth, and it was mainly a silicate ice core. The planet hit Jupiter with an impact speed of 46 kilometers per second. Jupiter only lost a small amount of mass from the collision, but its original core was completely changed. Before the impact, Jupiter had a dense central core of heavy elements, and the rest of the planet was made up of hydrogen and helium. After the impact, the infant planet's silicate ice core merged with Jupiter's, causing Jupiter's core to become diluted. The heavy elements spread out and mixed with the outer layers of Jupiter. While this collision was a defining moment for Jupiter, it meant the end of the road for the other planet. So, what are the odds that the Earth's fate would be any different? Well, let's find out. The Earth orbits around the Sun at an average velocity of 29.78 kilometers per second. At this speed, if the Earth were to just leave its orbit around the Sun and head straight for Jupiter, it would take about 242 days to get there. Throughout our journey, Jupiter would shine like a bright star, growing bigger day by day, hour by hour. By day 6, Jupiter would appear as bright as our moon. Soon, we would start to notice our daylight becoming dimmer. We'll only get about 50% of our normal sunlight when we reach Mars's orbit. Luckily for us, the Earth's atmosphere would act as a buffer, so we wouldn't experience the cold right away, but that will only last a while, so you'll need to invest in some heavy-duty winter gear. To put it in perspective, Mars has a surface temperature of minus 63 degrees. So that's basically what we'd have to look forward to. Once we speed through Mars's orbit, we'll pass through the asteroid belt. We'll get to see beautiful meteor showers lighting up the sky, but we'll also be at risk with colliding with some of those meteors, so let's keep moving. After 242 days of traveling through our solar system, we would finally reach our destination, Jupiter. As the Earth is pulled into Jupiter, our planet's velocity could increase until it reaches 60 kilometers per second. That's 250 times faster than an airplane flies, so you'll want to hold on tight. Oh, and did we mention that Jupiter has 79 confirmed moons orbiting it at all times? So there's a serious risk that we could collide with any of them as the Earth is pulled in closer. And if we do happen to avoid all those moons, things would only get worse. As we crash into Jupiter, both planets' atmospheres will be compressed, rapidly increasing the temperature and essentially setting the air on fire. But at least we won't have to worry about colliding with Jupiter's core, because we'll never make it there. Our planet is too small and would burn up in the atmosphere before that ever happens. But this would have a huge impact on Jupiter, as the Earth's remains would completely mix into its atmosphere. So if you ever notice our planet going off course and heading towards Jupiter, you might want to jump off along the way. Maybe right as we pass over Mars. And if you want any pointers on how to make the red planet your new home, check out our new show, How to Survive. The advice you find there might help you set up your own little Martian colony. But that's a story for another What If.